today is, tomorrow's Halloween. Okay. All right. Liquids. All right. What do we know about liquids? Cal, are they stronger or weaker than gases? How do you know? Very good. Liquids have stronger intermolecular forces of attraction. And when I say stronger, I mean than gases. If you want to write than gases, go ahead. And how do we know particles are closer together? They're more dense than gases. Closer together. Okay. Two things liquids can do, gases cannot. Caitlin. I still don't know how to say your last name. I'm ashamed of that.
I told you.
I forgot.
Oh my gosh.
How'd you say it?
I
want to say wise. What was wrong with me? Weasenborn. Okay. I'm sorry. I apologize. Can you tell me two things or one thing a liquid can do a gas cannot? Just because it's already a liquid. So gases can't do this because it's already a gas, but liquids can do this. Good. What do we call that? He just said it. You didn't hear him?
No, I'm done.
Okay. All right. Fair enough. What'd you say? Evaporate. Liquids can evaporate. I almost forgot how to spell evaporate. Or, now, here's a really, really bad way to explain this, but good at the same time. This happens really slowly, Brian. This word is kind of like this, but happens really fast, kind of all at once. No. Instead of evaporating, which is kind of slow, if I throw the water on the table and let it sit here for a day or two, it'll evaporate slowly. But how do I make it evaporate really fast all at once?
Boil it.
Brian. Good job, Brian. Boil. Yes. I'm going to start renaming people in here. All right. You're Caitlin. She's Brian. So that means you're going to have to be Cody, I guess, on that one, Brian. All right. So, yeah, evaporating and boiling are kind of the same thing, sort of, right? It's going from a liquid to a gas, but they're very different. Now, here's a fun question. Raise your hand if you know how to boil water at home. Everyone's hand should go up. Come on. All right. Who wants to explain how you would boil water at home?
Me?
Go ahead, explain.
Okay, so you put water in a pot,
In a pot?
put it on the stove,
Yep.
turn the heat up, and just let it sit there and slowly it'll boil.
Okay. Or
All
quickly
right.
if you turn it up pretty high, right? Okay. So where you put water in a pot, and then you put the pot where?
On the top of on the stove.
On the stove top. And what does that
Where
do?
the heater things are.
The heater thing.
Okay.
The burner.
Yep, that.
Yep.
Okay, and then.
Who has gas?
Okay,
Yeah,
stay
that's
there.
the best for cooking with. I have
Same way,
electric.
guys.
Because you can regulate the temperature much easier with the gas, and it's more efficient, I believe. But anyways, sometimes it smells, right? You have that smell in your kitchen,
Yeah.
and it goes like tick, 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 and it won't always light.
Yeah, when you need propane or something.
Yeah, or just it just won't light right away for some reason. All right, so okay, so now next question. Raise your hand if you think you have to heat that water to boil it at your house.
What do you mean?
Raise your hand if you think you have to use heat to boil water in your house. It's not you. Who are you, Jake Kyer? This morning, Jake wouldn't answer my question because he's like, "This is a trick question." I'm like, "Just answer. Do you live in a house that you need to heat water to boil?" And he didn't want to answer it. Yeah, the answer is yes, right? You all need heat in your house. Okay. Do you think there's another way to boil?
Yes.
Yeah.
Obviously, because of how I'm talking, right? That's why
What you
you're.
just said. You're like, well, if I could just put it on this desk, it would evaporate.
But that's not boiling.
But still, it's going somewhere else.
What's the difference between boiling and evaporating as far as what you see?
One bubble.
Evaporate.
Bubbles, right? You see bubbles in boiling? Evaporation, not so much.
Yeah.
And temperature.
Okay. Just what you observe and you can see. You can't really see the heat, right?
Oh.
You can't see it.
You can't.
Okay. I'm gonna blow your minds here.
Alright.
All right, evaporating. This is kind of a lengthy description, so stay with me. The liquid particles must
you.
Plus, gain energy slowly from. So if I took the water in my water bottle and just threw it on the floor or on the table, it's going to gain energy from where? Yeah, the surroundings. Table, the air, the floor. From the surroundings. From the surroundings. Liquid particles they have to gain energy from somewhere or else they'll never evaporate. They must gain energy slowly from the surroundings in order to do what?
Evaporate.
Yeah, but we need more intelligent answers.
Being turned into a gas.
Yep. Here's a liquid. How do they become a gas?
Spread.
Good. It's not that easy. What's holding them this close? Force of attraction. So they must gain energy in order to break the forces. Very good. To break.
Mr. McCoy,
Yes.
the camera isn't pointing all the way on there.
Yeah, I think it is, even though it doesn't look it.
Okay.
I think so.
You've got the tiniest square. It's like.
Yeah, I know, but it's confusing. I think I'm good. Thanks, OD. In order to break forces of attraction, to form a vapor or a gas. It's kind of wordy, but it's important to get all those words down. The bottom line is, to summarize this, the particles, when liquids evaporate, they're gaining energy from somewhere to break those forces in order to become free to move around like vapor and gas. And the funny thing is, this explanation can apply to boiling, but it doesn't really have to. Here's how you boil. Here's the definition of boiling. It's very short compared to this. A liquid boils when the vapor pressure, and you don't really know what that means yet. I'm hoping to explain it today, if not tomorrow. A liquid boils when the vapor pressure of the liquid equals the air pressure. Nowhere in that definition of boiling did I say anything about heat or energy, because it's not really needed. When the air pressure equals the vapor pressure, it boils. When we go up a mountain, on top of Mount Everest, what happens to air pressure? It drops. Very low pressure, right? So that's why the boiling point changes, because the air pressure changes. Where you live affects the boiling point of water. Now, most of us live in the same altitude, but if Cody were to live thousands of feet above me, his boiling water in his house would boil at a different temperature than mine because his air pressure would be different. So what is vapor pressure? Just really quick, so I'm running out of time. When this is open, is the liquid in there evaporating, or will it?
Eventually.
Yeah, eventually. Okay? That's vapor coming out of here. We can't see it, but it's there. What's that word pressure mean? How's pressure created? Collisions. When gas particles collide, we call that? Stay with me. When gas particles collide, we call that gas pressure. When air particles collide, we call that air pressure. When vapor particles collide, vapor pressure. Now, hold on, we're not done yet. Right now, the vapor pressure isn't very strong because it's escaping. What happens if I do this? It will build. If I left this sealed for a few days and I took it off, it would make that noise. We'll talk more tomorrow. Don't forget the book work for homework. And I will be at